Welcome, everybody, to Weekly Quantum World Detangled, Season 2, Episode 5.
I'm Denise Ruffner. I'm Chief Business Officer at Cambridge Quantum Computing, coming to you from Southern California. And Tommaso?
Hello, everyone. Good morning. Tommaso De Maria, CEO of Entropic Labs, calling you from Singapore.
My name is
Hi, everybody.
I'm the CEO of Interference Advisor, and we have a special guest calling us from a part of the world that we haven't covered yet, and that is South America, or a little farther north. But Martin, please introduce yourself and where you're calling from.
Hi, everybody. I'm Martin Machin. I'm co-founder of Quantum South. I'm calling from Uruguay, Montevideo, in Latin America.
Well, it's a pleasure to have you. I'd love to hear how you ended up in quantum. Quantum, there, is a lot of people like Tommaso with fancy degrees and things that I don't really understand, and just young geniuses waiting for a Nobel Prize. And then there are people like you and I, right? We have 20, 25 years work experience, that consulting, SAP, and all these other things, and now we're in quantum. How did you end up in quantum?
Well, actually, quantum computing was one of the emerging technologies of my interest that I have been following for a while. And last year came the opportunity to join some efforts in the University of Montevideo in Uruguay, where they led a workshop about the Qiskit platform with one professional from United States. And well, I participated there. And since I was following this quantum computing thing, I had learned about Airbus in Europe launching a quantum computing challenge for some aviation applications, quantum computing. So after that workshop, I told the guys in the university, why don't we explore participating in this? So we have so smart engineers, multidisciplinary teams here. So let's give a try. And we started to study those problems, and we decided to go there. So we spent several months working on that. We finally submitted a solution, and we were excited about quantum computer. We had physicians, civil engineers, chemical engineers, quantum computing engineers, computer science engineers. So we said we have a nice team. Let's continue working with that. Lot of mathematicians, a lot of maths in the problems. So we felt very comfortable with that, and we continued working. As part of the work that we had to do for Airbus, we had to do a research of the state of the art. What were the technologies? What will happen in the future? When those solutions could be possible to be run in the hardware. So we connected with many people and the main vendors. And as we were speaking with people in Europe, in North America, we felt very comfortable. So we said, okay, let's continue for that. We created our startup, Quantum South. And that's how we entered. Then the journey continued. And we did many more things. We came to meet with Denise, with André, and here we are.
Good, and we'll explore that a little bit more in a second. One more question for you, since you and I share a similar background of consulting, enterprise technology, a little bit of business education. Do you think people like you and I have an advantage also in quantum technology, something from our experience that might be beneficial that others in the industry might not have?
Definitely, I think we have an advantage because working with in the consulting space, I spent almost 9 years working for Tata Consultancy Services, working from Uruguay Global Delivery Center for customers in in North America, in Europe, global customers, and Latin America for sure. But we had the expertise of how to sell solutions to large companies, to sell how technology could be applied for particular businesses. And this is another technology for us. So even, for example, in my case, even I love mathematics, but I'm not the mathematician guy here. I'm not the physician guy here. But I can help companies to use technology to address their business. And this is one of my key components here, helping this startup. The international experience is an advantage. How to do consulting is an advantage, particularly when we have to educate companies how to take advantage of the quantum computing technologies that will be evolving and will be available across the years. So definitely,
beautiful message. Thank you, Martin. Let's learn more about Quantum South and Quantum in South America. Denise?
Yeah, Martin, I'm so glad you're on this podcast. It's our first South American person. And I'd like to just hear more about quantum computing in South America. Are there do you know of a lot of other people doing quantum computing in Uruguay or in other countries?
Well, actually, it's very, very emerging. There are people that are doing some kind of research at university level. We are finding some other startups. We heard something in Colombia. We came to know some people in Argentina connected with UK, but it's very, very, very emerging, and we are finding ourselves evangelizing people. We are participating with IEEE in different activities, just conveying what we are doing. And yeah, it's emerging. And the Inter-American Development Bank did a research about how is quantum computing in Latin America or in the Americas, and they found that Latin America is still lagging in investments regarding quantum computing. It's not comparable at all what is happening with North America, Europe, China. So this is emerging. That's why we are leveraging our talent in South America, working in North America, Europe. That is where the action is happening today.
And I believe that you were part of an incubator in Singapore. Could you tell us a little more about that?
Well, actually, the incubator has been in Europe, in UK and Spain. And this incubator is IoT Tribe. They also have a branch in Singapore. So we have been connecting with all people in Europe and Singapore. The IoT Tribe is creating cohorts. We participated in one in Europe. Now they have launched another one in Singapore for Asia. It was a space technology kind of startups, everything that is related to aerospace. And well, we were the only quantum computing startup there. We came with the idea of optimizing the load of cargo containers in aircrafts. And this is the idea that we developed. So we are creating a product to optimize the cargo in airplanes and ships. And also, we will be exploring financial services because of the nature of the problems that we are getting involved with. It is very familiar, so we want to continue that opportunity. This was a great experience, and we are very excited of seeing what is happening in Europe, in UK particularly, or all the things that are happening in quantum computing.
Well, in return, we're all very excited about what's happening in South America and the emergence of the industry. And now you're partnered with Rafael Sotelo. And who else is part of your company? I think you're 3 or 4 people, or?
Actually, we are 10 people.
10
Rafael Sotelo, Dr. Rafael Sotelo is the Director of Information Technology and Communications in Universidad de Montevideo. He's an active member of the IEEE. he is attending always the CES in Las Vegas, where he brings all the technology, and he met the IBM guys with the quantum computing. So he is one of the key co-founders of this company. And the other members are professors in the university with different backgrounds, and the students. So this is the team that is having with us.
That sounds great. I'm going to hand it over to Tommaso for some questions.
Sure. Thank you, Denise. And very nice to meet you, Martin. Thanks for joining us. Also good to hear that you're involved with, with Singapore. It would be great if you can come here at some point that we can meet in person. But something I would really love to talk about, or to discuss a little bit more, is about the technology that you're employing, and how you're thinking about quantum computing specifically for this kind of problems in optimization, which is, by the way, a great choice. We at Entropica work a lot on quantum or quantum-inspired optimization. So I'm really curious to hear what maybe I should say what is the unique approach of Quantum South. And I think a good way to start is with the hardware. Are you working or are you testing your solutions on any specific quantum computing architecture, or are you still working mostly on the theoretical simulated level of things?
Actually, we are working in both at the same time. When we started to evaluate the optimization problem, we came from the traditional models that we used to have in engineering to optimize things in loading. And there was a very well-known problem called knapsack. Knapsack is a problem where you put something into a bag till the capacity is complete. We learned how to solve it with the traditional methods. This is an NP-complete problem where it is not easy to find the perfect solution. So you have different calculations and algorithms and have some techniques to address that problem. The beauty of quantum computing is that you can address this problem in a larger space that is not possible to do with the conventional computers. So you can explore solutions in a time frame that is not possible with a conventional solution. So we expect to reach better results when we are able to run with the necessary qubits for that. So we started to work from some papers with that. We implemented a solution in Qiskit with IBM. So it was like mapping the theoretical thing for the particular problem that we addressed. We have to fine-tune and create a particular equation for that. We mapped it into Qiskit, and we did our best to scale it up in the IBM platform. So as we researched all potential platforms, because we wanted to ensure portability and not be tied only to a single platform, we started to evaluate how we could run in other platforms, perhaps with different technologies. IBM is coming with one universal quantum computer model, but D-Wave, for example, is coming with the adiabatic model that perhaps is suitable for optimization. And currently, we are testing the algorithm in D-Wave using the binary quadratic model. So our solution was based in the variational quantum Solver. There was an algorithm based on that. So now we migrated it to the binary quadratic model of D-Wave. We are excited because we are able to scale it up in that platform, in the Ocean platform. We are also testing the Amazon Bracket platform, where you can access the D-Wave machine. And at the same time, because we wanted to do that in many platforms, we came to know about the Cambridge Quantum Computing new platform called TK, that you can work in a high-level language, and in this platform, it will be compiled to different machines. So this is good for us because we will be able to test different machines without having to develop in the own platform like we did for D-Wave. So we are able to test in different platforms. We are talking with many vendors, and we will see. So our next step would be to somehow do a performance testing of how the algorithms is performing in the different platforms for different complexity size. So, we have to think about how many containers we can put together in an airplane. So we started with something that is 5 to 10, but now we are trying to go to 50 and more.
Got it. Thank you. Thanks. Very interesting. And do you think, looking ahead, that let me ask it this way. So do you think you will be able to extract interesting solutions to these hard problems in the few tens of qubits or maybe few hundred of qubits regime, or this is really more an exploratory approach that is needed while we wait to reach the so-called fault-tolerant regime? Or another way to ask is also, are you really excited and you think there are potential applications for near-term quantum computers or not?
Well, actually, we are expecting 3 years to have a workable solution with the current trend of availability of computers and qubits. We expect to divide the problem just to reach a whole solution if the number of qubits is bigger than what we have today. So our approach is to divide problems and run it there. So we are optimistic that we can do something in a horizon of 3 years. So that's what we are expecting. And in the meantime, we will develop the product and help companies to navigate this journey of quantum computing and prepare themselves to use this technology.
Got it. Thank you. I'll pass it to André, who I know has a few questions for you.
The famous Marcel Proust questionnaire adapted to quantum technologies. Martin, I have 12 questions for you, some of them a little bit more personal, some more technical, and your challenge will be to answer in one word to one sentence. If you start talking too long, I'll cut you off. And this is not about right or wrong answers, but what you're feeling, your emotions, and your personality.
Okay, perfect.
Right, Martin, what is the principal aspect of your personality?
Working hard.
What do you desire most in terms of a quality in an entrepreneur?
Achievement.
What do you desire most in terms of quality in a scientist?
Finding something new.
Or searching?
Or searching, but actually finding.
What is your best virtue?
Humility. Being very humble with whatever you do.
What is your biggest flaw?
Perhaps anxiety is something that you need to control sometimes.
I know that feeling. What do you appreciate most about working in quantum tech?
Well, challenging things, pioneering things, and emerging technology. Everything new for everybody. And this makes people be equal.
Yeah. If not a quantum tech entrepreneur, what would you be doing right now?
I came from a dairy industry family. We have a dairy farm, so I enjoy doing that with my brothers. So it's completely different.
Very interesting. Who is your favorite entrepreneur?
Well, this is a tough question. I have decided not to have one, but I have to recognize that today I'm following what Elon Musk is doing, because he's doing too many things that is important to look at. And he's not doing anything in quantum computing as of now.
Yep. I'll make it even more difficult for you. Who's your favorite scientist?
Well, Ray Kurzweil is somebody who taught me a lot of things. I was professor of artificial intelligence for many years in the university, and when I came to know him, I followed him a lot. He wrote several books. He's a technology forecaster. And well, he is today working in Google behind natural language processing, Gmails, and many things. He aims to create a mind. So very interesting things I learned from him.
Great. Back to quantum computing. What is your favorite quantum computing modality? Superconducting, photonics, trapped ion, topological?
Still learning. Not decided yet. I have to learn.
What is your quantum dream?
Make it happen soon. And I'm expecting that this is not a hype and that this will be a reality.
What is your quantum nightmare?
Well, the nightmare is the overpromise, that we are scared about that. So we expect that we are dealing with reality and not overpromises.
Imagine it is not hype and we make it reality. Tomorrow, you own the first universal quantum computer, fully fault tolerant. Who would you give it to?
Well, when that happens, we have to see the shift in security, because the current security mechanism for the private-public key will be broken. So we should shift that solution. So this is the first thing that we will see. And everybody will have to change the keywords and all those RSA mechanism. So this is the first thing that we should see.
Thank you so much, Martin. To my friends and sponsors, Denise from Quantum Computing, future Nobel Prize winner Tommaso from Anthropica Labs. Martin, best greetings to Uruguay. Great to learn a little bit more about what you're doing. This concludes Season 2, Episode 5 of the Weekly Quantum World Detangled. You are now detangled.